The question we are solving now belongs to test series 10. It is of digital electronics subject. In specific, it belongs to counters. As per the question, there is a modulo 6 ripple counter as shown in the figure. The modulo 6 ripple counter contains three flip-flops which are JK flip-flop. The flip-flop 1 has an output of A, and the flip-flop 2 has an output of B, and the flip-flop 3 has an output of C. The output A is given as a clock to flip-flop 2. The output B is given as a clock to the flip-flop 3. It is given that the terminals J and K of all the flip-flops are connected to a high of 1. It is given that the clear bar signals of flip-flop 1 and 2 are fed from a OR gate, and the OR gate accepts an input of X and Y. If the circuit acts as a modulo 6 ripple counter, we need to find the values of X and Y. We know that when the circuit acts as a modulo 6 ripple counter, the input should change, the output should change from 00 till 101, and the moment ABC changes to 110, all the flip-flops should be reset. For all the flip-flops to be reset, sorry, this is CBA. If all the flip for the, but there is no need that the flip-flop 1 needs to be reset because it is already 0. From this we can say that C and B needs to be reset. So from this we can say that if X is equal to C and Y is equal to B, then all the flip-flops which produce the output B and C needs to be reset. That is, the flip-flops 2 and 3 needs to be reset. When X is equal to C and Y is equal to B, there should be a clear signal sent to the flip-flops 2 and 3. That is, XY bar that is equal to CB bar needs to be given as a clear signal to the flip-flops. And we know that by De Morgan's law, this can be written as C bar plus B bar, and this is equal to X plus Y. From this, we can say that when X and Y are B bar and C bar, once the counter value ABC reaches 110, all the flip-flops will be moved to the state 0, 0. Hence, the correct option which corresponds to the values of X and Y is D.